When considering locomotive cable for general wiring, the National Electrical Code, or NEC, recognizes RHH or RHW2 conductors for use in general wiring applications, and this information can be found in Table 310.13. The odd sizing of a 535 MCM conductor, as opposed to a standard 500 MCM, is not specifically addressed in the NEC. However, the 535 MCM conductor can still be used provided its ampacity is calculated according to NEC guidelines. For a standard 500 MCM conductor, the ampacity is typically 380 amps at 75 degrees Celsius, as indicated in Table 310.16. When dealing with the non-standard 535 MCM conductor, you can calculate the ampacity using the formula outlined in Section 310.15, subsection C. This formula essentially relates the conductor area in circular mils to its rated ampacity per circular mil, and then factors in the conductor's temperature rating. Applying engineering supervision, the formula is ampacity equals conductor area in circular mils multiplied by rated ampacity per circular mil, all divided by the conductor temperature rating. Using this formula, if you assume a rated ampacity of 0.769 amps per circular mil squared and a conductor temperature rating of 75 degrees Celsius, the calculated ampacity for the 535 MCM conductor would be approximately 410 amps. It's important to emphasize that the results obtained from engineering supervision should be conservative. This means the calculated ampacity should be equal to or less than the actual ampacity that the conductor can safely handle. Beyond ampacity, the use of the 535 MCM conductors also necessitates adherence to specific sections of the NEC. Specifically, Sections 314.28 concerning the termination of conductors, and 312.6, which deals with transformer overcurrent protection, must be considered. The contractor is responsible for ensuring that the transformer being used is appropriately rated for the calculated ampacity of the conductors. In conclusion, utilizing the 535 MCM common cable with its RHH or RHW2 rating is acceptable, contingent upon calculating the ampacity through engineering supervision as per Section 310.15, subsection C of the NEC. The calculations must yield conservative results and comply with all relevant NEC requirements for both termination and overcurrent protection.